All right, give me a characteristic that made Pierre a good scientist. Yes. I didn't hear you.
Pierre likes to improve things, improve upon things around him, and
Improve on things. What else? Anything else? Yes?
He learned from his mistakes.
Ah. Anything else? Yes.
By the end of the short story, he knows how to connect the scientific method.
Yeah, so now he's learned the scientific method. He likes to ask questions. He's inquisitive, right? He's curious. All these things make for good scientists. All right, what was wrong with Pierre's first dog experiment? Yeah.
You only had one group and you didn't have one of those in the regular dogs.
Okay. Well, we call that the no control group, right? If you want to see whether or not your special vitamin mix is going to cause an effect, you have to have two groups, one with and one without, to see if there's a difference between the two groups at all. And so you can't have just an experiment without having the very important control group. What two mistakes did he make in his second experiment? Yeah.
he used different kinds of dogs.
Okay. What else? You's fine. That's fine.
I said also they may not have, like, they may not be the same age or like gender.
Yeah. Anything else? Not same age, gender. Yes. Food was different. Good. These things are all called constant variables, right? He needs to maintain constant variables between the two groups. Because if they're different, then you can't attribute any changes to the dog food, because it may have been the dog breed, it may have been the amount of food, it may have been the time that they were feeding. So everything's got to be the same. We call those constants, except for the manipulated variable, right? The independent variable that you're changing. Which was the control dog and which was the experimental dog in Pierre's third attempt? Why?
Because he was like just feeding it regularly, like having change, and then A was the one that got the special.
Right. A had the special mix. We call that the manipulated variable, also known as the independent variable, right? The thing that we're changing to see if it causes an effect on the dependent variable. Why was the control dog important to the scientific experiment? We already explained last time, right? We have to compare the experimental group, the thing that we add the independent variable to, and see if it causes a change. And we can't see if it causes a change unless we have a control group to compare it to. We must see if all things equal, does adding this one thing cause the dependent variable to change? What was the independent variable and what was the dependent variable in Pierre's third attempt? This is extremely important. Sarah Simmons. Okay, independent variable, you said how much the dogs grew, and you said dependent variable was the dog food. Now remember, did the dog food depend on how much the dogs grew, or did how much the dogs grew depend on the dog food? Exactly. So the dependent variable is going to be dog growth, because remember guys, the dependent variable, picture the guy in a lab coat looking at a clipboard. What is he writing down? Because that's the dependent variable. Is he writing down the dog food type, or is he writing down every day how much the dog is growing? Okay. This is what we are measuring, or we can just say observing. Okay, we don't know what it is until we perform an experiment. It depends. This is the dog food or the mix, right? Right, the thing that we're changing. What kind of scientific instruments did Pierre use? Chris? Like, what type of instruments? Like tools? That would be like tools. What type of tools did you use?
A scale.
Scale. Anything else? Yep. Yeah, he used the dogs themselves, absolutely. But in terms of the tools that he used, like to in the experiment, those are going to be the things outside of the specimens that he was testing. So a scale would be that videotape. Yeah, he was video them, right? Video camera and tape. What else? Measuring cup. See how much food, right? What else? Okay, so anything that a scientist used throughout the experiment, those are the instruments or the tools. What kind of data did Pierre record? What did the data look like? And we're going to refer back to the warm-up on this. What did the data look like? Jay?
What kind of data?
Yeah.
Like, did he record, like, how much the dog did?
So what did the data? What was that? How did he record how much the dog? What was the data? What was he writing down?
He was writing down how much the dog grew.
Exactly. So what was the data?
The amount that showed the next year the dog had.
No. The data that he's recording was not how much, although I'm sure he did measure how much food he gave him, but the dependent variable is how much the dog grew. What would that data look like? Yes?
Dog's weight.
Weight or mass, right? Is he measuring the growth by centimeters? Like how tall the dog is getting? Or is he measuring the dog by its kilograms, its weight, right? Its mass. Okay? Because this is a scientific method, we're going to use kilograms, right? We'll talk about the metric system. If he was doing, let's say, height, he would use centimeters, right? Or meters. If he was using qualitative data, he would just take pictures of the dog, right? This is all quantitative. Qualitative, right? Quantity, that's all about numbers. Qualitative has nothing to do with numbers, right? So it would have to be like the quality of something. It could be video of the dog or pictures of the dog. Those are data. It's still data, but it's not in the form of a number. Both of these could show me how much the dog is growing, but they're not necessarily going to be exactly in the same way. So we have two categories of data. It could be quantitative in a number or qualitative. How could you explain how you could recreate Pierre's experiment? Yeah. Yeah, but the food, you're not measuring the quality of the food, right? You're measuring the growth. And you can measure the growth in two ways. Qualitatively, which is not associated with a number, right? I can just visually see him getting larger by looking at pictures, or quantitatively. The quality of the food, I mean, it makes sense. If it's good quality, it'll make him grow. That's not necessarily exactly what we're talking about when we're talking about qualitative data. So how would you recreate the experiment? Yes?
Like, we can take, like, two plants and give one of them special bit of a special vitamin mixture fertilizer, and the other one you don't give it.
Okay, so you could do this with plants, or maybe another type of organism. Because maybe it was just that dog that was growing faster. You would definitely need to recreate this experiment with other dogs. If you use a plant, maybe this is dog food, it only works on animals. So if you used a plant, it's definitely not recreating the same experiment, because the experiment was to test the growth on dogs and the growth on animals. So there may be some flaws in that. Why is it important to repeat scientific information? Yes?
Because your first experiment isn't going to always be correct, so the more you test it, the better.
Yeah. This is to eliminate the sources of possible human flaws, right? If you did it one time and one time only, then there's nothing to say that there wasn't bias within the scientist or if there was any human flaws in the experimental design. But if you repeat the experiment 1,000 times and you're always getting the same conclusion, then that's good science. So remember, the final step of the scientific method is to publish and repeat the experiment.